Hi, I'm Troy. Behind the camera is my dad, Tom, and this is the GT1 project, such as it is. Right now, standing in the shop. The shop is a mess, but there's a lot of stuff in here. There's about 4 years worth of stuff. Somewhere in all of this, there's an airplane. The airplane's not built yet, but the molds are here. And I'm hoping by summertime there'll be a thing on sitting in this room that looks like an airplane. Probably won't fly, but it'll at least look like what I'm trying to do. What I'm trying to do is pretty risky. There's a lot of technical risk. There's some physical risk. I'm taking an unproven propulsion system and attaching it to an unproven airframe, and well, that's risky. But you know, sometimes there's just no other way, and for me, there's no other way. There are 50 molds here. They're going to make 100 parts. This white stuff is wax. So these have been waxed. They're ready to pull parts out of. I've only pulled enough parts. I pulled the parts 4 years ago for the fan system itself. This is a ducted fan. This is a 13B Renesis motor. It is a 6-port Renesis. It is, this is a JDM engine. This is one of the 50,000 or 30,000 kilometer pullouts that they sell out of Japan. Seems to be in reasonable condition, but it's still going to get completely rebuilt. Down here on the floor are all the parts that we don't need. Some of those are going to go back on. Coils, the alternator. The air conditioning pump is going back on because it's only 7 pounds. So that's going back on. For a 10-pound weight penalty, we're going to be air conditioned. So this is the version that this flywheel is for the automatic transmission. I am developing an intake. It is almost done in CAD. I am developing an exhaust, which is also almost done in CAD, and there will be a turbocharger limited to 5 psi here, basically for normalization. We're going to run it within its designed envelope. We're going to run it in the 200 horsepower range at max, and we're going to try and cruise around 120 horsepower. The fan is designed to run at those numbers at the speed that I want.
And that's powered by this motor, right?
The fan itself is carbon. The hub is 7075 T6. This is the hub. Okay, this is a custom designed cut hub. These fit in with a dovetail, but the dovetail is not the retention mechanism. There are 3 1/4-inch bolts that are the retention mechanism. The design force is 15,000 Gs. This is 5 ounces. This one's a little light. They're going to be somewhere in the vicinity of 7 ounces.
A little thicker.
A little bit heavier, but you know, this is a delicate balance because heavier this is, 15,000 Gs comes up quick. So there's thousands of pounds pulling this out. These are the molds. I made these years ago. These are poured epoxy molds. And these blades are hollow, except for the base, which is monolithic carbon. And then there'll be 3 holes and 3 bolts to retain it. The dovetails are really only for position. I'm not relying on them to retain. Just I want to be a little bit closer to the load here. So I've got 3 bolts on the inside. These 3, 1, 2, 3, 1/4 28ths. This is a Dorman Gubbio, and the basis of this is C5 Corvette. C5 Corvette.
Oh, good.
Okay, this inside the transmission tube of a C5, you will find this attached to the shaft. So that's where I began, because I knew that I could get parts. Okay, and these are a tried and tested thing. We're in the same realm of power and RPM that they're going to run at, and so I felt like this was a good bet. This will also isolate this from the shaft, from the engine. where the torsional vibrations come in. We're just gonna have to test. I don't know. I don't know where all that's gonna fall out. There may be problems, there may be not, but we're gonna have to test that stuff.
So this is going to be in the rear of the airplane, right?
This sits, and we can go over here. I can kind of show.
Yeah.
So these are the molds. These are not the parts. The parts are inside here, but this is roughly the configuration. I haven't really dealt with these in years. Sad to say, but it's true. We made these like 2 years ago. This is the canopy. Rear passenger is 3-4 inches higher than the front passenger. Front passenger is stuffed all the way up front here. Rear passenger, firewall, wing, engine sits right here, and it's just getting closer and closer and closer to the firewall. I'm within a couple inches of the firewall right now. Then the shaft, and then the fan system. And at some point I'll come down, we'll stop. I'll bring what I have of the fan down and show some finished parts. But that fan sits here. It is 24 inches nominal diameter. The outside is another 3 inches around the outside, so it's about 32 inches outside diameter of the casing. The center section, we can go back over here.
This is the wing right here, right?
This is the wing. This is the top of the, okay, this is kind of like a Lancer in that the top of the wing flows all the way around to the bottom, okay?
So this is the outside of the mold of the wing, am I right?
Right. In here is the plug.
And
then there's
the part you're going
right,
to use.
Right. That's the shape, right? And then there's gel coat, all epoxy, 6 plies of 10-ounce glass, and then I shot it. I had a company come in and shoot all this. I'm not sure I'd do it again. I've seen a little bit of shape change, especially as it pulls in on those flanges.
The reason you put the foam on the back is
to stiffen it. And we did that, and we did that here on this fuselage mold, and it worked beautifully. But we'd used the pour foam. We used the AB foam, and that seems to be a little bit more stable than this stuff. But we had the guys come out for $1,000, and they came and shot all this stuff. And in principle, yeah, we just had them shoot it on the back. And I think in general it worked very good, but I think in these corners, as it shrank, it pulled these a little bit more than I was comfortable with. So what I'm going to have to do is just kind of, I'm going to saw this and relieve that tension, you know.
Fill the relief hole there.
Yeah,
or the
yeah.
slot.
I had to do some of that here. So this part goes from underneath the wing all the way across to the top of the wing. And so it bonds to the rear spar and the front spar. And so there's no joint at the leading edge. It's going to be a hell of a thing to lay up, but it'll be okay.
And those pieces up there, that's like the cockpit, am I thinking right?
Yeah, so that part there is the rollover structure, and it's a separate item that gets bonded onto the fuselage, and it goes right here. And it's the firewall, and it's the rollover structure. And it basically goes in right here. And then the canopy flips forward. I just couldn't find any better way to do it. I tried to flip it from the side. It just doesn't work. The shapes are too complicated. There aren't straight lines in this thing. The OML of this airplane aren't straight lines. So let me grab something.
So this airplane is really ready to full mold and put together.
Yeah.
The mold full and ready to go, right?
Yeah, this is an example of the part. All right, so this basically is 1 ply, core 1 ply. This is 1 ply of carbon fiber, a 1/4 inch foam core, and then 1 ply. And then there are there's I think I put 4 around the edges to stiffen the edges up.
It looks like my artificial leg.
It does. I mean, that's the same stuff. That is the same stuff that they used.
Yeah.
Yeah. This is called a 2x2 twill.
It looks good.
And it's 2 over, 2 under. So the fibers go like this.
The new leg looks just like that.
Yep.
Beautiful.
Yeah, yeah. It's great shit. These are the molds for the horizontal stabilizer. These are the plugs they came out of. So when I generate a plug, I just go at it old school. Well, it's not completely old school. I start in the computer. I design everything in the computer. And then I pull station formers. In this particular case, I only pulled two. This one and that one, and then these reliefs. And then foam in between, carve, a couple plies of glass, usually one or two. Micro balloons, bodywork till you cry. And then wax it, PVA it. And to get this return, I just put pieces of wood here. Now I use the edges as a document. The edges here are actual part line documents. I like to get as much out of the mold as I can. If you're going to go through the trouble, get as much out of the process as you can.
Am I correct in saying that everything was engineered first and done on paper and scattered out before you ever start building it?
You know, I've done it the other way. I mean, back in my youth when we were building Bear Coots, where I cut my teeth and all this, I mean, David would be in the shop all night, right? And he would just go for it, and he'd make a part in the morning, and he'd go, draw this, right? And that's one way of going about it, but I don't do that anymore.
This
I
thing,
can.
You've got all the paperwork for this. You've got.
Well, yeah, I'm working through all the paperwork.
Yeah.
I draw first, or I design first, then I draft, and then we'll make it. Because otherwise, you end up wasting a bunch of material that I don't have.
Show a picture of the completed project in this.
Yeah,
video.
I'll cut to some of the CAD.
Where this is going. Yeah.
I'll cut to some of the CAD out of this, but the reality is I'm a professional in this area, and that's how I do it, and that's what's expected of me in a work environment, and I just don't see a reason not to do that here, because there's too much invested, there's too much time invested, there's too much risk not to use the best tools I have. Now that doesn't mean that, look, if I had all the money in the world, we could just farm this out and cut $10,000 worth of tooling block on a CNC mill, and it would have been done already. But I don't have that kind of money, so I have to kind of.
Would it have been done that easy, that fast? What you're doing here on a CNC?
I wouldn't have had to spend 3 years sanding, that's for sure.
What's the sanding? Yeah.
Right. So with the model,
this stuff is baby smooth, baby skin.
Yeah,
smooth.
it has to be, and so that takes a long time to develop that surface, and it's long boards.
I know you've been at
for
this
years.
for a while, but
this, right?
I mean, it's hard to see right now if you don't visit, but these.
Yeah.
This is a plane
No,
in here
before,
already. You just,
So and that's something that most people are not prepared to do. They're not physically prepared, and they're certainly not mentally prepared to go that deep in the bodywork. It's a lot of bodywork, and it comes up from nothing.
I've done enough bodywork to know
Yeah.
it's an art and a skill.
Yeah, and I personally enjoy it, but it's also it's brutal on your
Tedious.
body. It's tedious and it's brutal on
hard
your
on
body.
your fingers and your arms.
And I am glad to have that part behind me mostly.
Yeah.
Now for the smaller stuff, I'm finally to small stuff. Over there in the corner is a, this is the Snapmaker 350. It's a combo machine that does, 3D printing, CNC, and laser. And, they upsold me to the 10 watt laser, which I have yet to really use that much. I use it mostly as a 3D printer. I'm finally to the part where there's some stuff that can actually go on this bed that you can actually 3D print and it be useful. But to this point, all the stuff was so big, I just basically had to do it by hand. There was no other practical way for me to go about it.
I think you made the joystick handles or something.
I did. They're in this box. I designed a complete joystick, which is now completely catted up. So this brings up another subject. This is an awesome core. So what I did, I haven't done it to this one yet, you just wrap this in one ply of 2x2 twill carbon, and it becomes extraordinarily strong and light. This is very light, but if you look at this stuff, I'm not sure at work, we use a lot of 3D printing. And you can get Ultem 3D prints that are flight worthy, no question. This is just a PLA, but if you wrap this in 1-ply carbon, it becomes extraordinarily strong and pretty much flight worthy. So I'm going to explore a little bit more in terms of using 3D printed PLA cores. Okay, ply of carbon, core, ply of carbon. That way, instead of just having flat piece, I can have whatever shape of core that I want. All right. So the traditional way of doing this stuff is you laminate your outside, you do the core, you laminate the inside. It's a tried and true sandwich composite. But sometimes you need a core of a specific shape. This is a really good way to do that. So I'm going to keep exploring on that. But these are going to get wrapped in 1-ply of carbon, and then they get an aluminum piece put in here, and then these are channels for all of the wires to come out. And this bolts through and then clamps down onto the tube. And I'll bring up some CAD on this, but basically front seat, rear seat, and they just go like this. It's a slider mechanism, and yeah, that's basically the primary control system. It's all bolted, and again, I can back this up with some CAD. You okay, Dad? Yeah. It's all bolted to the seat. FYI, this is the gantry that we built because we've got to get all this off the floor in order to get this place usable again. Because in 4 years, we just filled it.
And the gantry is made to pick up all these heavy parts?
The gantry is really made to stow and carry the wing molds and to get them on top of this, on top of the fuselage molds, so that we can stow all this efficiently against that back wall. So this is the seat mold. And then all of the controls go into here, and they're on sliders, so they serve both the front and the rear seat. And so I want this to be this is designed as a SRU essentially.
SRU stands for?
Shop Replaceable Unit. Okay, a benchable assembly. This thing is broken down into big benchable assemblies. This can be loaded with all of the systems, the primary control systems. It can be done on the bench, tested, and then dropped into the airplane. So that's one of the goals. I want to have as many things being able that you can do on the bench and plug in as you can. Just makes it easier. And if you've ever maintained an airplane, been upside down underneath at 100 degrees, hating your life, I'd like to avoid that if I can design around it. So this is the mold that creates both the front and the rear seat. This is the entire front seat, and the rear seat's got to get trimmed down a little bit. We'll keep this part, but these will have to get opened up because the rear seat geometry is a little bit different, but I don't want to make a whole mold for the rear seat.
So if you envision sitting in that, that's where the seat's going to be.
Right, this is upside down, right?
Yeah, it's got your
so here's the seat, here's the butt.
Yeah,
it is designed around a long softy.
Positive side of the negative that'll come out of there.
It's designed around a long softy, which is a type of parachute. It's called a long softy. It's mostly for helicopters. I mean for sailplanes and long easies, that sort of thing, with a bench seat. Comes up and over, 17 inches at the butt. It's kind of, look, airplane design especially it's the art of compromise and negotiation. You're always compromising and negotiating with everything else. You're constantly balancing weight and cost and mission, but the better you are as a negotiator, the better you're going to be as a designer. But it's just one of the basic tenets. It's just a locus.
The smoother the airplane, the more it cuts the air, the more efficient, faster it is. So
the more you sand, the more you have to sand. You can build an airplane much easier than this. It's called an RV-10. Okay, and it's a tried and tested thing, and that's great. There's a bunch of them on this field. I don't want one. This is worth it to me to try and get the performance I think.
What is this going to be?
Pardon?
What is this going to be? A small, light,
small.
fast,
it's a
efficient.
little. I call it the Nearjet. Okay. The goal is high straight wing, slow jet, fast prop performance. That's the goal. Whether or not I get there or not is a whole other question, but the goal is to be as fast as like a World War II prop plane.
Yeah.
Okay, but the key characteristic here is smallness.
Yeah.
17 feet by 17 feet, 45-ish square feet of wing area at a 0.0038 coefficient of drag on the wing. Laminar surfaces, I know what those are, I know how to get them. We're going to have to see how.
Yeah, but what you're after here?
What I'm
what's
after.
going to come is a B-51 Mustang small,
Right.
or a performance of a Mustang.
Slow jet fast.
Yeah.
Okay?
Otherwise, you could save it.
Fast prop fast,
Yeah.
slow jet fast is the goal. Whether or not I reach it or not,
Yeah.
look, listen, if I'm even close, it's still a really cool airplane. Okay.